Hi students, welcome to Max video classes. In the previous video, we completed some definitions and one problem in exercise 3.2. Now in this video, I'm going to explain next problems in exercise 3.2. Let us start exercise 3.2 problems. Second one, state whether the following statements are true or false. What is that? State whether the following statements are true or false. First one, the sum of three odd numbers is even. Is it true or false? The statement is false. False statement. Why? Because the sum of three odd numbers is always odd. First, we check the result once. We take three odd numbers and add them. We check the result, odd or even. For example, 1 is odd number, 3 is odd number, 5 is odd number. First, we add these three odd numbers. We check the result. 1 plus 3 plus 5. 1 plus 3 plus 5. 1 plus 3, 4. 4 plus 5, 9. 9 is odd number. 9 is odd number. We check another example. We take another three odd numbers. We take, that is 7, 9 and 11. These three are odd numbers. 7 plus 9 plus 11. 11 plus 9, 20. 20 plus 7, 27. 27 is also odd number. The sum of three odd numbers is always odd number. That's why this statement is a false statement. This statement is false statement. Next statement, the sum of two odd numbers and one even number is even. The sum of two odd numbers and one even number is even. First, we check one example. We take two odd numbers. 3 and 5. These two are odd numbers. Another one, we take even number, one even number. 4 is an even number. We add these three. We check a result. 3 plus 5 plus 4. 3 plus 5, 8. 8 plus 4, 12. This is even. 1, 3 odd numbers and 2 is even number. We add these three. What is the result? 1 plus 3 plus 2. 1 plus 3, 4. 4 plus 2, 6. 6 is also an even number. Here the result is even number. The sum of two odd numbers and one even number is even. This is the result, even number. That's why the statement is a true statement. Why? Because true statements? Because the sum of two odd numbers and one even number is always even number. The sum of two odd numbers and one even number is always an even number. Next one, the product of three odd numbers is odd. The product of three odd numbers is odd. We check with one example. The statement is true or false. We check. We take three odd numbers: 1, 3, 5. These are the three odd numbers. Multiply them. We check the product. 1 into 3 into 5. 1 3s are 3. 3 5s are 50. This is odd number. The product of three odd numbers is odd number. We check another example. We take three odd numbers: 3, 5, 7. 3 into 5 into 7. 3 5s are 15. 15 7s are 105. 105. This is also odd number. We take any three numbers and any three odd numbers and multiply them. The result is always odd number. That's why the statement is true statement. True state. The product of any three odd numbers is always odd number. If an even number, next one, if an even number is divided by 2, the quotient is always odd. The quotient is always odd. We check with one example. For example, 12. When it is divided by 2, what is the quotient? 2 table 6 times 2 6 are 12. Remainder is 0. The quotient is even. Quotient is even. We check another example. 6. 6 is an even number. We divide 6 by 2. What is the quotient? 2 3s are 6. Remainder is 0. If an even number is divided by 2, the quotient is always odd. This is a false statement. Why? Because sometimes quotient even number, sometimes we get an odd number. That's why the statement is a false statement. Next one. All prime numbers are odd numbers. No. Why? Because except 2 remaining are all odd numbers. 2 only even prime number. That's why the statement is a false statement. Already we know that the statement all prime numbers are odd. The statement is false statement. 2 is only even prime number. Remaining prime numbers are odd numbers. Here the statement is all prime numbers are odd. That's why the statement is false statement. F1. Prime numbers do not have any factors. Prime numbers have only two factors, that is 1 and the number itself. Here the statement is prime numbers do not have any factors. That's why the statement is also false statement. Next one. Sum of two prime numbers is always even. Sum of two prime numbers is always even. We check with one example. With examples. Take two prime numbers. 2 and 3 are prime numbers and add them. 2 plus 3. 5. We take another two prime numbers. 5 and 11. These two are prime numbers. 5 plus 11. 16. So the result, sometimes we get odd number, sometimes we get even number. That's why the sum of two prime numbers is not an even number. This is false statement. Because the sum of two prime numbers is either odd or even. Either odd or even. Next one. 2 is the only even prime number. Yes, 2 is only even prime number. The statement is true. 2 is only even prime number. Remaining prime numbers are odd numbers. That's why the statement is true statement. All even numbers are composite numbers. What is the statement? All even numbers are composite numbers. The statement is false statement. Why? Because 2 is even number. What is composite number? Composite number have more than 2 factors. That the number is composite number. 2 has only 2 factors. That is 1 and 2. That's why the statement is false statement. Because all even numbers are not composite numbers. Example 2 has the factors 1 and 2 only. So it is a prime number but not a composite number. That's why the statement is false statement. The product of two even numbers is always even number. Yes, the statement is true. We check with one example. 2 is even number, 4 is even number. The product of two even numbers is always an even number. 2 4s are 8. 8 is even number. 4 and 6. 4 6 are 24. 24 is also an even number. That's why the statement is true statement. The product of two even numbers is always an even number. Let us do next problem. Third one. The numbers 13 and 31 are prime numbers. Both these numbers have same digits, that is 1 and 3. Find such pairs of prime numbers up to 100. Find such pairs of prime numbers up to 100. First we write such kind of numbers. First we will write all prime numbers up to 100 and observe that prime numbers. Let us find such kind of pairs. All prime numbers up to 100 are these: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89 and 97. These are the prime numbers up to 100. Out of these prime numbers, a pair of prime numbers having same digits. First pair already is given, 13 and 31. 13 and 31. The pair is same number of digits that already given. Second one, we find it. The pair 17 and 71. These two numbers having same digits, that is 1 and 7. We write second pair 17 and 71. The two numbers having same number of digits, 1 and that is 1 and 7. Next pair we find. Next pair 37 and 73. 37 and 73. These two are same number, same digits, have same digits. That is next pair 37 and 73. These two are have same digits, that is 3 and 7. Next pair 79 and 97. These two numbers are also have same number of digits, that is 7 and 9. 79 and 97. These are the prime numbers, a pair of prime numbers having same digits. Hence there are 4 pairs of such types. Let us do next problem. Write down separately the prime and composite numbers less than 20. Already we know that prime numbers are those numbers whose only factors are 1 and the number itself. The prime numbers less than 20 are what are the prime numbers? A number, those numbers have whose only factors are 1 and the number itself. 2. Next one, 2 has only 2 factors, that is 1 and 2. 3 also, 5 also, 2, 3, 5, 7, 11, 13, 17 and 19. These are the prime numbers which are less than 20. 2, 3, 5, 7, 11, 13, 17 and 19. Next we write composite numbers less than 20. What is composite number? Composite numbers are those numbers which have more than 2 factors. Such kind of numbers are composite numbers. Composite numbers less than 20 are first composite number 4. 4 have more than 2 factors. Next one 6. Next one 8. Next one 9. Next one 10. Next one 12. Next one 14. Next one 15. Next 16 and 18. Here 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18 are composite numbers which are less than 20. This is the prime numbers less than 20 and composite numbers less than 20. Let us do next problem. What is the greatest prime number between 1 and 10? What is the greatest prime number between 1 and 10? First we will write prime numbers up to 10. Prime numbers between prime numbers between 1 and 10 are 2, 3, 5 and 7. These are the prime numbers between 1 and 10. What is the greatest prime number in the following prime numbers? 7 is the greatest prime number. Therefore the greatest prime number between 1 and 10 is 7. Let us do next problem. That is sixth one. Express the following as the sum of two odd primes. Express the following as the sum of two odd numbers. Here the following numbers are 44, 36, 24 and 18. We know that every prime number except 2 are odd number. We know that every prime number except 2 are odd numbers. First, we can write 44. We have 44. 44 can be expressed as sum of two odd primes. For example, 13. 13 is prime number or not? Yeah, prime number. This is odd prime number. Next one, 13 plus 31. We add these two, we get 44. And 44 can be expressed as sum of two prime numbers. That is 13 plus 31. 13 plus 31. What is the result? 3 plus 1, 4. 1 plus 3, 4. This is the 44 can be expressed as 13 plus 13, 1. These two are odd primes. Or 44, another one, we can express 3 is odd number and 41 is odd number and odd prime number. 41 also odd prime number. 3 plus 41 is also 44. 41 plus 3, that is 44. We also 44 we can write also 3 plus 41. These two are odd prime numbers. We have 36. 36 can be written as 5 plus 31. 5 and 31 are two odd numbers, two odd prime numbers. We add these two, we get 36. 5 plus 31, 36. Or 13 plus 23. We can write also 36 is equal to 13 plus 23. 23 plus 13. 3 plus 3, 6. 2 plus 3, 30. 36. We can write next, you can write next C1, D1. Same way. 24 and 18. You can express the sum of two odd primes. Let's stop here. Remaining problems we will do in the next video. Thank you for watching.